Most of us use them every day to cook our food, but does anyone really know how microwaves work? Microwaves, the waves, are an actual form of energy that is used in microwaves, the appliance, to heat your food. In terms of wavelength and frequency, microwaves fall between infrared radiation and radio waves. In case that form of reference means absolutely nothing to you, a microwave is about 12 centimeters from crest to crest, or 10 to the minus 2 meters. This wavelength is easily absorbed by most foods, especially water molecules, which cause the foods to heat up. We'll get into the specifics of that in a second, but on to the most important question. Do microwaves give you cancer? Despite what your grandma might have told you, the particles that make up a microwave, photons, do not possess enough energy, or the right energy, to cause cancer. Similar but more powerful waves like ultraviolet and X-rays possess more energy per photon and can cause cancer. Now that we understand a little bit more about the dangers of microwaves, how do microwave ovens themselves work? Something called the magnetron is the core technology of microwave ovens. No, it's not the name of a transforming robot. Rather, it's essentially a high-voltage motor for creating microwaves. An electrical transformer converts 120 volts AC from a wall socket, in the US at least, into 4,000 volts or higher to feed into the magnetron. The high voltage heats a filament at the core of the magnetron, causing it to release excess energy as electrons. These electrons would normally fly outwards from the cathode, or the filament, to the anode, the positive terminals, but a circular magnet bends them back towards the filament. This bending from the solid-state magnet causes the electrons to fly in a sort of loop. In a grander scale, as these electrons are being sent out from the filament and are flying in loops, microwaves are being created. Essentially, the looping electron flies past anode terminals continuously. As an electron flies past an opening between anodes, it creates a microwave. Think of it as blowing across the open end of a bottle. Understanding how a microwave oven, or more specifically a magnetron, creates microwaves is key, but how do these waves heat up your Hot Pockets? Well, the microwaves are transmitted from the magnetron through an antenna. The microwaves then bounce around inside the metal casing of the microwaves in different patterns. These waves are then easily absorbed by the water molecules in food. Molecules absorb the waves, which cause them to start to vibrate, converting the energy into heat. Foods that are low in water content aren't normally affected by microwaves. Digging deeper into why the absorption of microwaves by water molecules causes the food to heat up, we have to look into electric fields. Water molecules, just like magnets, are positively charged on one side and negatively charged on the other. Microwaves are also positive at their top crest and negative at their bottom crest. As a microwave hits a water molecule, the molecule tries to align itself with the field of the wave. Since microwaves are in fact waves, their positive and negative fields are constantly moving, roughly 2.5 billion times a second in the case of microwaves. This combined with the water molecule trying to align itself with the changing fields means vibration. Vibration means friction, and friction means heat. So we now know what microwaves are, and we know how they heat food. But why do they heat food so fast, and why are there often cold spots in our food? Microwaves heat food so fast because they cook all parts of the food at the same time. A pan cooks food only through conduction, where the food is in contact with the pan. Since microwaves pass through every aspect of the food being cooked, it can be heated both internally and externally simultaneously. But that also means there can be cold spots due to the nature of waves. Cold spots in microwaved food are caused when microwaves cancel each other out. When a positive side of a wave and a negative side of a wave hit each other, they cancel out to equal no wave. Thinking of it more rudimentarily, I've broken it down into this award-winning equation. 1 heat plus negative 1 heat equals 0 heat. This equation and the underlying scientific principles cause dead zones in microwaves where no heating occurs. This is why most modern microwaves will include a spinning platter. The spinning moves the food in and out of the dead zones, producing more even heating. All that just about covers everything involved in the function of modern microwaves. These devices have become crucial to our daily routine and involve a decent amount of science and engineering. Hopefully, now you'll never be able to look at a microwave the same way again.